What is going on, guys? Welcome back. In today's video, we're going to learn how to use SQL statements to query data from Pandas DataFrames. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so obviously for this video, we're going to need Pandas, which is an external Python module, so we need to install it. And in addition to that, we're also going to need Pandas QL, which is basically Pandas SQL, but with only one S, so Pandas QL, which is also an external Python module. So in order to install those two, we open up a command line and we type pip install, first of all, Pandas if you don't have it already, and then pip install Pandas QL to allow us to do the SQL querying with Pandas DataFrames. And then what you need is you need some data frames. So you can either use something like Pandas Data Reader to get some financial data from the web. You can create your own data frame by creating a dictionary, parsing it into a data frame, or you can import just some CSV file, which is what I'm going to do. So I have here this simple CSV file where I have the ID, name, age, height, gender of a bunch of artificial people here. So we have 1 to 8 for the ID. We have a bunch of names here. We have ages and heights, and then we have MF for male, female. That is just some sample data. You can create whatever data you want. You can put it into a CSV file and then you just import it. So the focus is not going to be obviously on the data. The focus is going to be on querying using SQL statements. And for that, we're going to start by importing pandas as PD, which is the usual alias, and by importing pandas QL as PS. I'm not sure if that is like the go-to best practice alias, or if you would use an alias at all, but we're just going to use PS for this video here. And now we're going to say data equals PD read CSV, and we're going to get the data.csv file here, and we're going to say data set underscore index is going to be ID, and we're going to assign that to data, and then we're going to take a look at it by printing data to see if that works. And now you can see we have name, age, height, gender as the columns here. We have the ID column, which is the index, and this is basically what we have now. And now we might want to find, for example, all people that have an age above 30, for example. Now, before we go into the SQL querying, we're going to do a simple pandas query to see how it would work without SQL statements. So what we can do here is we can say print data.query, which is a pandas function without using pandas QL. And here we can just specify a string expression that is the query that we want to have. For example, we can say, okay, the age has to be above 30. And then what happens is we get only the entries where the age is above 30. So you see 1, 3, 5, 6, 8 are the IDs where this is the case. We can also, of course, say greater or equal to 30. And then we get, I think, an additional record here, Anna, because the age of Anna is exactly 30. So this is how you do it without SQL, and this is fine. You can also do stuff like, for example, gender equals, and then single quotations F to only get the women, as you can see here. So this works, and this is the simple way to do it with pandas, with only pandas. Now we can use pandas QL to do the same thing with SQL statements, and for that what we can do is we can say print, or actually let's first define the SQL query in a statement here. We can do something like select everything, so select star from, and then essentially what we have to provide here is we have to provide the data frame. So in the string we're going to say data, and this name here has to be the same as this name here. So this query will be used on this data frame here. So the data frame will be treated as a table, which it is essentially. So this is a database table now. And we're going to say select everything from data where, and then age is greater than 30, for example. And then what I can do now is I can say print ps sqldf, so ps.sqldf, and then we execute the SQL query, and we pass the locals function here as well. And then you can see we have the exact same output. So now the difference here is that we get now, again, the ID as a column here. So we have now a different index. We could also just store the data frame, set index to ID again, and drop the index that we have here. But essentially, we get the entries that we're interested in. And of course, we can do the same thing here with, for example, gender equals I think we need to provide it here again in single quotations, right? There you go, gender equals F. And I think we should also be able to do and, so age is above 30. I think this should work as well. There you go, we only have one entry left here. So this works. And we can do even more complicated stuff. Like, for example, let's say we have now data 2, which is going to be a second data frame. We're going to just create it now from scratch. We're going to say here the pandas data frame of a given dictionary, and the dictionary is going to have an ID list, and it's only going to have one ID in that list, ID 2. And then we're going to say that we want to specify a job here, and we want to say the job list is just programmer. So this is essentially just a data frame. Now we can actually print this. Data 2, let me just, oh, come on. Data 2, let's comment this out here. This is now just a simple ID job data frame that we have here. Now we can take this and merge it. We can join it via an SQL statement to make an advanced query with Pandas QL. So what I can do here now is I can go ahead and say the SQL query that I want to make is the following. It is select everything from data, and I can also provide an alias like D. So select everything from data D, left join, and then I can say data2, D2 is the alias now, on D.ID is the same as D2.ID. And of course you can play around with more details, you can make it more professional and everything, but we can now go ahead and say print ps dot sqldf SQL query, and then locals again. And then you will be able to see that we have now, ignore the first column here, but that we have here now Anna, which is ID 2, and she now has a job. All the others do not have a job. This is because we did a left join, which means that we keep all the entries even though the job is none for all of them. We could also drop this second ID column here. But essentially, since we joined on the ID, we now have for Anna, which has the same ID here, the job programmer. This is just some very basic example, but that is how you do it. This is how you can use SQL queries to get data from data frames, and you get a resulting data frame from that. So you can get a smaller version of the data frame where certain conditions are met. You can do joins, you can do a lot of things. You cannot do everything. I think stuff like I tried to do, I think, a full outer join, and I think the error message said it's not supported as far as I remember. There you go. What was it? Right and full outer joins are not currently supported. So you have some limitations here, but essentially this is how you can do it in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and